Assalamualaikum warahmatullah. In this session, we will discuss about labor demand in the long run. Remember that when we say the long run production process, in order to produce certain amount of output, let's say Q0, it is a function of capital and labor. And in the case of a long run, both capital and labor are now become variable inputs. So in this discussion, we want to understand how a firm would adjust the combination mix between capital and labor in producing the profit maximizing output level in the long run. To present that idea, we start by looking at the following diagram, and this diagram is called the isoquant curve. All points along this isoquants Q0 would give us the same amount of outputs equal to Q0. So the combination mix of capital and labor in this case, as indicated by point X, is that in order to produce Q0, the firm may employ certain amount of capital, let's say K1 over here, and also certain amount of labor, let's say E1 over here. So this is one input mix combination that the firm can consider to produce Q0. Alternatively, the firm can also produce Q0 as indicated by this point, Y, where the firm may hire K2 amount of capital and E2 amount of worker. So this is another possible combination. Another thing about isoquant curve is that isoquant Q1 lies much higher than Q0. It tells us that all points as indicated by Q1 here means that the firm is producing more outputs as compared to isoquant Q0. And in order to produce Q1, the firm need to hire more capital and also more labor because Q1 lies above Q0. So this is the basic idea of isoquants. Quite similar in the context of indifference curve. These are some properties about isoquants. It is a downward sloping curve. Isoquants do not intersect. Higher isoquants means higher level of output. The shape of isoquant curve is convex to origin. Therefore, from the diagram, we learn that the capital-labor combination along the same isoquants produces the same level of outputs. You can refer to point X and point Y as indicated earlier. Now let's compute the slope of isoquant. The slope of isoquant is given by change in K, capital, over change in labor, E. If we do the calculation, the following is the slope of the isoquant. It is given by marginal product of worker over marginal product of capital. And we get this negative sign because isoquant's curve is a downward sloping curve. The slope of isoquant also is known as the marginal rate of technical substitution or MRTS. The slope of the indifference curve is the marginal rate of substitution MRS. Let's say we want to change the combination input mix between capital and labor. We are now moving from X to Y as indicated in the diagram. So the gain in output due to higher employment, because now moving from X to Y means we are hiring more worker, is expressed by this term, where change in employment times the marginal product of worker give us the gain in output. Over here, as we hire more workers, there should be gain in output, and the gain in output is given by change in employment times marginal product of worker. So this expression tells us how much gain in output when there is change in worker here. Likewise, over here, when there is change in capital, but now less capital is taken for this production of Q0 output level, we want to know how much there is drop in the output when we decrease the capital intake. For that, it is given by the following expression: change in capital times marginal product of capital. Therefore, since these two terms, they are cancelling out one another because we are moving along the same isoquants. Therefore, we can put them together where change in worker times marginal product of worker, this will give us the gain in output from hiring more workers. And the second one here, change in capital times marginal product of capital, this will tell us the decline in output as we adjust the capital intake. So these two basically would cancel out one another because we are producing the same amount of output. So these two therefore will equal to 0. If we rearrange this expression where we bring change in capital over change in worker to the left side and the remaining other terms to the right hand side, you will get this expression. So this is how we derive the slope of the marginal rate of technical substitution for our isoquant. Convexity of the isoquant implies that the law of diminishing marginal rate of technical substitution. In other words, the isoquant is flatter as firms substitute more labor for capital. That's why the shape of the isoquant first it's steep and then it's getting flatter as we move from point X to point Y as indicated in the diagram earlier. So that's about isoquants, its properties, and how we derive the slope of an isoquant. Over here, we want to bring another important diagram that is called the isocost. Isocost is something like our understanding on budget line earlier. But isocost represent the idea of cost to our firm when the firm wants to produce certain amount of output. As indicated here, we have capital on the vertical line and then employment or number of workers on the horizontal line. So first, we need to know what's the cost of our production process. All points along these isoquants, they are equally costly. For this line, the isocost has the cost outlay of C0, and for this isocost is with the cost outlay of C1. Because this isocost C1 is much higher than C0, all points along C1 basically are more costly than C0. The slope of isocost is equal to the ratio of the input prices, W over R. And the negative sign is because isocost is a downward sloping curve. We will later establish how we get this slope. In order to compute the slope of the isocost, let's first understand the cost function. We can express the cost for the firm as follows. Cost is given by the wage rate W times E, and this will give us the cost of hiring certain number of workers plus R times K. R is the cost of capital and K is unit of capital. We then can rearrange this expression as follow, where we bring K to the left side of this equation. Why? Because if you look at the diagram, we put K on the vertical line. So then K is equal to, now I replace cost as a capital C, cos C over R minus W over R times E. So in order to calculate the slope, we find the change in capital over change in employment, and it is given by the input prices W over R, and it should be negative. How to get to this? If we look at this equation, and if you make the first order different, change in K over change in E, you will be left with only negative W over R. And this is the input price ratio. So this is how we calculate the slope of the ISO cost. So what we have done in the discussion so far is, number one, we have looked at the isoquant over here. We also have established the concept of marginal rate of technical substitution given by the slope of the isoquants. And then over here, we have discussed about the cost function for the firm, and it is represented by isocost. And we also have discussed about how to compute the slope of the isocost. That's for the discussion this time. See you, inshallah, in the next discussion. Wassalam.